Alright guys, welcome to this set of video lessons. These videos are going to go along with Chapter 2, Section 3 out of your guys' textbook. And what we're going to be discussing in this section or this series of notes and video lessons is going to be slope. Right? We're going to do a lot with slope, which you guys would have looked at extensively back in Algebra 1. A couple of objectives for you or learning targets as we go through this set of videos, things you should be able to do by the time we get to the end of these videos. The first one is you need to be able to find the rate of change. Before we can begin our discussion on slope, we're going to need to talk about rate of change, and so that's the first objective that we're going to start with. After we get done talking about rate of change, we're then going to go ahead and begin to work on finding the slope of a line. Anytime we graph a function, you'll be able to find the slope of the curve that represents that function. So those are your two objectives or learning targets for this set of notes. Let's go ahead and jump right into an example here. What I've got for you is we're going to start by talking about rate of change, and I've got the definition here for you for a rate of change. Rate of change is a ratio that compares how much one quantity changes, generally on average, it's over a period of time, relative to the change in another quantity. Now, you will see, or you could see, rate of change expressed as any one of these. Please notice they are all equal to each other. So the rate of change is equal to the dependent variable, right? The change in the dependent variable, that's generally y, over the change in the independent variable, which in most cases will be x. We'll look at an example below where it's not x's and y's, but generally when we're graphing functions, it will be x's and y's. Well, that is the same as the change in y over the change in x. You may also see in math, every time we see the Greek letter delta, this is the Greek letter delta, it looks like a triangle. Delta will always mean change in. So we're talking about the change in y over the change in x. I'll use that one quite a bit. You know that change is a difference, right? It means difference, and difference is a fancy high school word for subtraction. So what you're going to be doing is you're going to be taking the change in y, or the difference in y, y2 minus y1 over x2 minus y1, which of course is rise over run. Honestly, for you guys, these are the ones that are going to be the most important. Make sure that you are familiar with these ones right here. Those are the ones we're going to see most of the time. Delta y over delta x, y2 minus y1 over x2 minus x1, or rise over run. We just describe it as rise over run. So now that we're familiar with rate of change, or just refreshed on what you guys would have seen in Algebra 1, I do have an example problem for you here, so let's go ahead and take a look at this. Now what I'm telling you here is the problem is the graph is showing the number of gallons of water in a swimming pool as it is being filled. At what rate is the pool being filled? Now what's nice about these problems, and the ones we're really going to start with here, is we have a straight line. All right, in order to fill a pool, you're going to put a hose into the pool, you're going to turn the water up as high as you can, but the hose is going to limit how much water is going into the pool at a time, right? The only way to get more water to go in would be to use a bigger hose, or to get less water going in would be to use a smaller hose. But as long as you're using the same hose, the rate that the pool is filling will be constant, right? We're limited by the size of the hose, and so that's why it is linear, right? But we want to find out what is that rate. Well, we said that it is the change, right? The change in y, so that's going to be my vertical axis, water in gallons, over the change in x, in this case the horizontal axis, which for us is going to be time. So let's go ahead and work this one out together. We just said that the rate of change, here we go, rate of change. So rate, am I standing in front of that? There we go. Rate of change is going to be equal to the change in y over the change in x. We call that y2 minus y1 over x2 minus x1. Well, what I need then is I need these points, right? I need the point x1, y1 and the point x2, y2. And where do those points come from? Well, they're going to come from our graph. Here, let's go ahead and put them in red so we can tell. This first point right here, 3 and 108, let's call that x1, y1. And the next point right up here, we'll call that x2, y2. Well, now that I know what my x1 and y1 and my x2 and my y2 are, all I need to do is plug those numbers into my equation, do a little bit of calculation. You can even use a calculator, just plug and chug, don't fat finger something on your calculator. It should all work out just fine. Watch your minus signs. So let's see how this goes. For me, my y2 is 252. And my y1 is 108. My x2 is 7. And my x1 is 3. So I have 7 minus 3. Now you go ahead and do a little bit. Like I said, feel free to use your calculator. Just don't fat finger something on your calculator. You should get 144 over 4, which is going to come out to be, if you do that division, 36. And then the units are going to be very, very important. Please remember, the y is on the top, and y is water in gallons. So I have gallons on top. The bottom is my x. The x's are time, like how long have I been filling the pool. So down here on the bottom, that time is in minutes, right? So that would be gallons over minutes, which means my units would be gallons per minute, or gallons over minutes. So we'll do gallons over minutes. What this means then is my number now has meaning. I have been filling this pool for however long it's been going. In fact, in this case, we can see we're all the way to 10 minutes here. So for every minute worth of time, I have 36 gallons of water going into the pool. 36 gallons per minute. And that, again, is because of the hose, right? That rate is not going to change unless I change the size of my hose. Bigger hose, more water will go in per minute. Smaller hose, less water will go in per minute, but we get a straight line. One last thing I want to point out here to you, and you should remember from Algebra 1, is this. I chose this to be x1, y1, this to be x2, y2. If you switch that, would you get a different answer? Well, let's find out. Let me go ahead and switch these. I'm now going to make this point x2, y2, and this point x1, y1. So really here the question is, when you're calculating rate of change and later on calculating slope, because you do it the exact same way, does the order matter? Does the order of the points matter? Is it important? Well, let's find out. We already know that in order to calculate rate of change, it's y2 minus y1 over x2 minus x1. So let me go ahead and do that right here. We're going to have y2 minus y1 over x2 minus x1. And let me plug in what I've got. Now my y2 is 108. So I'm going to have 108. And then we're going to subtract y1, y2 minus y1. Well, my y1 is 252. All right, now in the bottom, I'm going to have x2. Well, my x2 is a 3. That's going to be minus x1, and my x1 is a 7. Now, I apologize, guys. I have not already worked out this solution. Can you believe it or not? You're actually watching live math. I'm making this up as we go. The question we're asking is, I had flipped my points. This was x2, y2, and this point was x1, y1, and I got this answer of 36 gallons per minute. If you were to switch the points, would you still get the same answer that I get? So that's what we're trying to figure out. I've now switched those points, and if this comes out to be 36 gallons per minute, what that means, order doesn't matter. You guys can name any point x1, y1, any point x2, y2. It doesn't matter. You're always going to get the same answer as everybody else. That's what we're hoping for, right? Because if order matters, then it's one more thing that you have to remember. And yikes. So let's find out what happens. Here we go. We're going to have 108. Again, I'm going to need my calculator. Don't fat finger something on your calculator. 108 minus 252. I get a negative 144. I'm sorry, negative 144. Yes, negative 144. I thought I said negative 114. Not negative 114, negative 144. And in the bottom, 3 minus 7, it's going to be a negative 4. Well, let's see what happens. I already know that so far we're looking good. Negative divided by a negative is going to be a positive. So that's encouraging because this was positive. The question is 144 divided by 4, 36. Well, take a look at what we got. 144 divided by 4 positive gets me 36. When those minus signs cancel, I have the exact same problem I had down here. Yes, I still get 36 gallons per minute. And this is fantastic news because here's what it means for you. Order doesn't matter. Make whatever point x1, y1, make the other point x2, y2. You don't have to worry about the order. You're going to get the same answer, right? It's just one less thing you have to worry about, one less thing you have to remember. Order does not matter for rate of change. You're gonna get the same answer either way. Good stuff. That takes care of everything on this page of the notes. Head on over to the next page, and I'll meet you there.